Hey there. So let's have a conversation about abstraction. This is one of the biggest big ideas that you will deal with in this class. It's huge. And it's one of the seven big ideas of the computer science principles curriculum. We're going to see a lot of examples and of abstraction. And I'm just going to tell you, think the color purple, because in MIT App Inventor, abstractions are procedures and procedures are in purple. So think those things. Now, what happens is an abstraction is the process of creating abstractions. It's the process of making something simpler. So it's a general representation of some person, place, or event or process. Now, what happens is you're taking something that's very detailed and you're pulling out only the most important details. You're making it less than. If you're taking notes right now, you're actually creating an abstraction of this online lecture, right? Because you're actually taking the most important pieces of what I'm saying. I'm trying to put a lot of color around it, and you're saying, okay, well, what's the most important thing? Abstractions. Removing unimportant details and sharing only the important details, something like that. You're writing that in your notes. Now, you use abstractions all the time. So let's talk about what those are. You just don't call them abstractions. So here's some everyday examples. The first is this is a map. Now, if you think about it, and let's take a second and let's look at Google Maps, for example. Google Maps is not the actual person or the actual place. It's just a map, a description of something. Let's take a look at that right now, right? Maps.google.com. Now, this is an abstraction of the area. Now, I can get less abstract by zooming in, right? But then there's other ways of looking at this, and that's kind of one of the popular things um, about it. When you go to like satellite looks, now I can drill down, and this is a little bit less abstract because that is my neighborhood. That's actually some of my neighbors, and no, is that my apartment building? I think my apartment building's in here somewhere. I don't know. It's not, some of these people are my neighbors. I don't know where they are. And so anyway, that's kind of my current location. And so you're seeing what I'm talking about in terms of is a zip. Nope, this isn't my neighborhood at all. Sorry, I was incorrect. But I can get really, really deep, and I can get into something even called street view. And I can get even less abstract because now I'm seeing, street view and get all the way down to where people are. So those are examples of abstractions. Now, the next one we're going to talk about is a model. Now, this is a model airplane. Now, I could build models that fly. Those are less abstract than simple plastic models that I pick up at the craft store. So models are not actual airplanes. If you've been inside of an airplane, that's less abstract because it's an actual airplane. A model of an airplane is an abstraction of it. Floor plan, there's another one. The first day of school, when you were probably in elementary or middle school, they may have given you a floor plan. If you go to a college, they're going to give you a floor plan. That's an abstraction. Now, our ideas are formed through a process of leaving out details, right? For example, if I say the word chair, right now, you're thinking this chair. But if I ask you to close your eyes, so take a second, just play this game with me, and I'm going to say candy. Now, open your eyes and just think for a second. I didn't show you candy, but what if I was thinking of a Reese's peanut butter cup and you were thinking of a Jolly Rancher? That's the difference between the different levels of abstractions. Candy is very general, it's super abstract, and exactly what that looks like does leave things open to interpretation. Words are abstractions. We actually speak a language, and that makes it more abstract. You don't necessarily understand what machine language, zeros and ones, really looks like or really says, but we have translators that can abstract it into software that we can use. So while you're playing your video game, your game console is processing millions and millions of lines of zeros and ones, but you're just seeing stuff jump around the screen. You're seeing the abstraction. Now, in computer science, here's how it works. It's the process of simplifying, condensing, and encapsulating, and it's an important problem-solving skill. Abstractions in hardware and software help us reduce complexity. They make things easier to understand in computer systems. Now, a variable is an abstraction. And I do this in the slideshow, and I almost wish I had like a better way of showing this to you, but a constant, something like number 5, is always 5. But if I say x plus 1 equals 6, x can represent any number. If I put it in the world of plus 1 equals 6, then you know it's a 5. But if I put in x plus 2 equal, or sorry, x plus 1 equals 7, then I've just changed x because x is now 6. Now, this is a data abstraction example. We have an example of blocks, and we have this very same text right here, hello and welcome, hello and welcome, hello and welcome. Now, if I call it a variable, I call the greeting hello and welcome, and I put that greeting everywhere here, now I've got something called the greeting variable. So here I had it 3 different times. Put the text here, put the text here, put the text here, right? But here, I stuck it in this variable. And then every time I need to use it, I just use the variable. Why would I do that? Well, you probably already figured out. Look at hello and welcome. It's misspelled. If I'm here and I have to fix it, I have to fix welcome here, and I have to fix it here, and I have to fix it here, and I have to fix it here. And that's a pain in the neck. So if I go over to here and I put it in here, and I say, this is the variable, greeting. I go and change it, and it's automatically fixed in all these spots. That's why we use variables. Variables are huge because they make it possible for us to put stuff in one place and edit our code across an entire app. Now, computer languages also have procedures that perform calculations for it. This is another level of abstraction. This one, SQRT, is actually square root. And so if for example, if I want to do the square root of 5, I use that square root code, and I tell it to look at 5. And that, of course, is going to give us 2.236. The square root simplifies the process. I don't have to write out the whole square root formula. I can simply say, just do this. Give me the square root of whatever number's in the parentheses. And that's what this is about, that square root piece. Now, here's what's called a procedural abstraction. Now, it's a little bit difficult to understand if you're not used to looking at it. So let's take a look at it together. Global X. Now, global X is the height of something. Global Y is the width of something. If you remember height times width, height times width is the area of a square, right? I think we've known that. That's like back in middle school math. You know that already. X, X times Y, or height times width, is going to give you the area of a square or rectangle, right? We know that. Now, to get Z, which is the area, I'm going to multiply global X by global Y, right? But here's the thing. This is getting me the area of something. The area of label 1 is blah, blah, blah. Look at this. This is right here. Give me X is the height, Y is the width, multiply the 2. This is height is X, width is Y, X times Y. It's the same exact stuff right here and right here. The same exact information in 2 different places. That's what we call code smell, because it stinks. And it's repeated code, and it's a pain in the neck to maintain. So we do something called calculate area. And you don't have to know exactly how this works. You're going to get really good at it. But look what I did. This purple, remember when I said purple is a procedure? Purple is a procedure, and a procedure is an abstraction. Purple is a procedure, and procedure is an abstraction. If you haven't written that down yet, write it down. Purple is a procedure, and a procedure is an abstraction. So X times Y is going to give me an area. It's always going to give me an area. So I can do all kinds of stuff, and I'll call this procedure, calculate the area, and I'll tell it to look for an X and a Y. And so as long as I feed it an X and a Y right here, it'll always give me the area. If you don't know how that works, don't worry. The idea is if I have a thing that I do over and over again, I call it a procedure, and I just keep using that procedure all over the place. Now, getting back to it, if there's a calculation problem, which one's easier to maintain? And this is not a great set of slides. If I have to fix this and there's an error in this, I have to fix it here, and I have to fix it here. That's what they're saying. If you don't do a procedure, I got to fix it everywhere it occurs. And if I have 3 different places, I have to fix it in 3 different places. If I call it a procedure, I edit it, I fix it, I edit it and I fix it right here. And I never have to go through the rest of my code to fix it everywhere else. I fix it in one place. Procedures make your code easier to understand and easier to edit. That's worth writing down. Procedures make things easier to understand and easier to edit. That's really important stuff to know. So to summarize, An abstraction, it's a simplified, generalized representation of something. Words, symbols, maps, models. Abstracting is the process of removing details and condensing information in order to focus on relevant aspects of the object or objects we are representing. Make sure you know both of those things. And then remember what I said. Purple is a procedure, and a procedure is an abstraction. As a matter of fact, they use the words procedural abstraction. Know those terms. If you get that, you'll be able to get through most of 2.8 on this. I hope that helps. Thanks for being awesome. Thanks for watching.